Hey everybody, today I want to talk about something I think that's overlooked way too much these days in the teaching of college algebra or just algebra in general. Writing down the domain at the very beginning is worth the time. Just take a look at this very first term in this radical equation. 3x plus 4 has to be greater than or equal to 0, right? But that certainly implies that x has to be greater than or equal to minus 4 over 3, right? Now notice what I've done down here. I've written down an interval notation, the possible domain of any solution that might exist here. This represents this right here, okay? This is called the closed. This bracket means minus 3/4 is part of the possible part of the domain, all the way out to infinity. So in other words, you could just, this is equivalent, this statement right here, this interval notation is absolutely equivalent to this statement right here. Okay. In a similar fashion, you can get a minus 1/2 that corresponds to this term, and also 3 to infinity that corresponds to this term. All right, so the intersection of these three sets, in a set theoretical sense, gives you the domain. Okay, so the intersection here is clearly the larger number. So 3 infinity is the smallest set, if you will. So you could, our solution or our potential solution domain is just 3 to infinity. Okay, and then put in a probably more user-friendly way, x has to be greater than or equal to 3 to be a solution to this equation. And that's clear just by looking at the so-called weakest link. This is kind of the set theoretical way to do it with the closed open interval. Now let's get into the solving. Now y'all, what I'm trying to get at is most people just dive into solving the thing and then check all the solutions for extraneous. This is the best approach. I don't know why it's not taught anymore. Okay, now, so we can re-express this guy like this, all right? Now, if we square both sides, and again, you're gonna have to square at some point, unless you wanna guess and check, which a lot of people take pride in doing, but we're gonna square both sides, and when you square this, you get this. This side right here is just the result. If you think of this part right here as A and B, okay, this is just the well-known algebraic identity, A plus B, quantity squared is equal to A squared plus 2AB plus B squared. And notice that when you square a radical, the radical just goes away, right? So that explains this B squared term corresponds to this because you squared this object and the radical just went away, right? So anyway, that's simple enough. You don't have to FOIL it out or expand it out manually, okay? Now, notice we get a nice thing here. You have the 2x here and the 2x here, which it was designed to make the problem easier, okay? So the 2x and the x cancel with the 3x right here. You get all of this, folks. Divide by 2, you get this, and then, of course, you square both sides. If you square both sides here, if we square both sides, we end up with all of this. Okay, and again, I won't go through all the details there. It's fairly straightforward. Now let's check and see if this factors. If it's going to factor, it has to at least look like this. Right? It's a good start, right? And you know you're going to need some kind of plus-minus combination. All right? And it's a trial and error process. There's trial and error no matter what method you're proud of on this, okay? So this ends up being x minus 4 and then 2x plus 3. Okay, now notice we would get two possible equations here. X equals to minus 3/2 would be a possibility. Okay, and also x equals 4. Okay, but let's remember now, what did we do at the very beginning of the problem? We learned that x has to be greater than or equal to 3. So without substituting minus 3/2, which is done all the time, and even in this textbook way back, this 1956 textbook did it this way, where They don't do this at the beginning, and yes, I'm ranting. They just substitute the minus 3/2 back into the original, but we can automatically reject this right now. I mean, what's the universal sign for negation? Just we can reject this one because what is it again? Minus 3/2 is less than 3. Minus 3/2 is less than 3, and all solutions have to be greater than 3, right? So let's check out 4 in the original, folks. If you put 4 in, and again, a lot of you probably just guessed and checked on this. That's another flaw of these sort of problems. I usually try to make the constants bigger. But anyway, if you try x equals 4 right here, you will get the square root of 16 minus the square root of 9 minus the square root of 1, right? And of course that's 4 minus 3 minus 1, so that does equal 0. So 4 checks. So 4 is the solution. X equals 4 is the solution. And again, I guess it's because domain is considered a hard topic, but stating the domain of the equation, of the left-hand side in this case, is the right approach, just pedagogically and conceptually, right? There's people that do videos all the time that don't do this, and then if you tell them about it, they act like what, you know? So it's really kind of it's amazing that how math changes and oscillates on the way it's taught. But anyway, x equals 4 is the only solution, and that is all, folks. Thank you for viewing.